Hello and welcome back, everyone. This video is for section 4.4 of my pre-calc class, trig functions at any angle, and you hopefully have some previous knowledge of chapter 4 for sections 4.1 through 4.3 of how to manipulate and use the unit circle in terms of the 6 main trig functions. So quickly, we know that if we are looking at the unit circle from what we've done before in sections 4.1 through 4.3, let's say we're taking and we're talking about pretty much here 30 degrees, okay? So talking about 30-degree angle right in here, all right? We know that if I asked for the sine of 30 degrees, we know that sine will always go with the y value, and we have that as 1/2. We know that the cosine of 30 degrees, cosine always going with the x value, is going to be radical 3/2. We also know that if we asked for the tangent of 30 degrees, we know that that is y divided by x. So we would take 1/2 divided by radical 3/2. And we know that that's going to simplify to 1 over radical 3, or if we rationalize it, radical 3/3. So this is what we've done before. And we know that we've talked about here that we know that sine will always go with the y value, cosine will always go with the x value, and tangent will always be the ratio of y divided by x. And we know that the other 3 trig functions for cosecant, that'll be the reciprocal of the y value. Secant will be the reciprocal of the x value. And cotangent will be the reciprocal of tangent, which is be then x over y. So all of these we know, okay, can be drawn as a triangle here with, taking into consideration right here, and we make a right triangle that goes with it. That's a pretty bad right triangle, but you get the idea here. Okay, so this right triangle right here, with this being our 30-degree mark, okay, we could use SOHCAHTOA and get our ratios like we did in geometry of a 30, 60, 90, and then 45, 45, 90. So those can come into play. But the main thing I wanted to review with you here are these ratios right here that we did. Now, the thing about these ratios is they are all based on the unit circle. All right, so the unit circle we have studied again up to this point. Now, the thing about the unit circle is the radius. Now, what was the radius of the unit circle? The radius of the unit circle is 1. Okay, so we know that that's going to be 1 from going from the origin out to these points. We know the radius is going to be 1, as we can see right here for the 90 degrees. If I go from right here to right here, that radius is 1. Okay, so we know that we're not always going to be with the unit circle and the radius being 1. What happens if we expand this? How do we take this information here now and go past the unit circle where our radius is no longer just 1? Well, the key is the radius. Now, as you can see here, if I go back and draw a triangle, all right, what do we know about right triangles that we've talked about in SOHCAHTOA before? All right, so we know that in a right triangle, one of the most famous things we have is the Pythagorean Theorem to help us find this radius. Okay, so we have an x here and a y here. We know that our radius can be used from the Pythagorean Theorem. We know that r squared would be the same as x squared plus y squared, so therefore r is the square root of x squared plus y squared. Now, it wasn't taken into consideration with the unit circle because the radius was 1 every time. But now if the radius winds up getting bigger, we have to know what that radius is. Okay, so the ratios that we get now come down to this. So the radius being, again, this is just from the Pythagorean Theorem, of r equaling x, the square root of x squared plus y squared. All right, so these ratios are now what we use. Now, same thing, sine's still going to go with y, but now it's y over r. Cosine's still going to go with x, but now it's x over r. Tangent and cotangent haven't changed. They're still y over x and x over y. But we didn't have to do r before because r was a value of 1 on the unit circle. So y divided by 1 was just y. So now, because the radius is bigger, we have to incorporate that new radius. So let's look at a real basic one right here. We got to find all the 6 trig functions according to the point -3, 4. So if we're looking at this, okay, I got an x and a y right here. So there's my x and my y. So all of these come down to just using the Pythagorean theorem. Got to find r first. All right. So that's going to be -3 squared plus 4 squared. So that is going to be, here we're going to have 9 plus 16 square root of 25, and we get 5. Is it always going to be a perfect square root? No, it's not. So sometimes you'll have a radical, sometimes you won't. So now we know everything we need to know. We know x, we know y, and now we know r. And now we can just plug those in. I know that the sines ratio is y over r. All right, so what was y in our problem? It was 4. 4, and then all over r, which was 5. So I have sine as being 4/5, and that means that cosecant is the flip or the reciprocal of that. We got 5/4. We know that cosine is x over r, and x in our problem was -3 over 5. And then the reciprocal for that is secant. So we will flip that and make that -5/3. And then last, we got tangent is still y over r. So that's going to be 4 over -3. And that means that cotangent is -3/4. So it all comes down to is finding r, finding the radius if we're given a point x and y. Okay. Now sometimes you'll be given an x value and an r value, and you have to do some algebra to find the y value or something like that. So you'd square both sides and go through that. This is the most basic problem we have right here. But the key is this. This is the key right here, is knowing all your ratios right here. Got to know what these are. Sine still goes with y, but now it's y over r. Cosine x over r, tangent y over x. Okay, so let's look at a little bit more complicated problem, because this is the easiest of the easy. You just got x and y, and you just got to find r. You plug them in. Okay, so sometimes you got to do a little detective work here. So let's take a look at one problem here that we have to think through some things here. So I got it here, one that requires some detective work here. So take a look at what we got. We got tangent of theta is -5/4, and cosine is greater than 0. And so the directions could say find all the other trig functions, find just sine of something like that, or so let's just say we're going to find all of them. All right, so as part of the directions for this one, we're going to find the rest. Okay, so let's figure out here what we know. Well, we know that tangent has a ratio of y over x. All right, so I know in terms of my x and y coordinate, I've got a 4 and I've got a 5, but I got a hang up right here of this negative. Does the negative go with the 5 or does it go with the 4? All right, so I don't know that right now, but here's what I do know. I know cosine is greater than 0. Cosine is greater than 0. All right, so in math, anytime you see greater than 0, that's a fancy way of telling you that something is positive. All right, so cosine's positive. All right, what do we know about cosine? Well, we know that cosine always goes with the x value. So if cosine's positive and cosine goes with the x, that means x is positive. All right, so if the x value is positive, that means that then the y value has to be negative. All right, so we did some detective work there. So that means we know now that that's 4 -5. And so now what we can do is just like the other problem. What do we got to find? We got to find r. Okay, so that's going to be the square root of 4 squared plus a -5 squared. So we're going to have the square root of 16 plus 25. So that's going to wind up being the square root of what there? That's 25 and 16. That's going to be 41. Now that doesn't reduce or anything like that, so that'll be all right. We can just leave it as the square root of 41. Okay, so we know everything we need to know. We know what x is, we know what y is, and we now know what r is. So now we got to find all of them. We know tangent's negative 5/4, but let's start off with sine. Sine, again, is y over r, and our y value was negative 5. And that's going to be over the square root of 41. Now, that's okay, but you know a lot of ACT or SATs and a lot of standardized tests are going to have that rationalized. So you have negative 5 radical 41 all over 41. Okay, we can do cosine. Cosine's x over r. So if I fill that in, that's going to be 4 over the square root of 41, which is going to be a 4 radical 41 over 41 if we rationalize it. And then tangent. Well, tangent was given, so don't screw that up. Tangent was negative 5/4. Alright, so now if we wanted to do the reciprocals, cosecant, we would flip this. Secant, we would flip this. And then cotangent, we would flip this. So that's how you can get all at once. So had to do a little detective work right there. Okay, so make sure you're looking at this. Greater than 0 means positive, less than 0 would mean negative, things like that. One other thing that shows up, okay, that I wanted to talk about real quick, and that'll help with some of these detective work problems as well, is when we're talking about trig functions in their quadrants. Okay, let's say we have an x and y axis here. Okay, one way to know what trig functions are positive and what quadrants. All right, well, let's think about this. First quadrant, we know x and y are both positive. So that means sine, cosine, and tangent are all positive in here because x and y. So now let's go over to quadrant 2. What's the only thing that's positive in quadrant 2? Y values are only ones that are positive in quadrant 2. So what do we know about what goes with the y value? That's the sine. Alright, what about down here in quadrant 3? Well, we know that they're both negative. So which one's going to be positive? Well, that's actually going to be tangent. And that is because we're going to have a negative x and a negative y. And when you divide two negatives, negative y divided by negative x, those are going to cancel. So tangent is the only one that's positive down here in the third quadrant. Then we go over to the fourth quadrant. What's the only thing positive in the fourth quadrant? Those are the x values. And the x values go with cosine. So this tells you then how you know what trig functions are positive in each quadrant. Now there's a little acronym. We use A, S, T, C. And we say, kind of a cheesy one, but we say that all students take calculus. And that is your acronym starting in the first quadrant. All of them, sine, tangent, cosine. All of them, sine, tangent, cosine. If you don't like that one, instead of the all students take calculus, if you start in quadrant 4 here, okay, it spells cast if you go counterclockwise. But you got to remember that you start down in quadrant 4 for that one, for cosine, for the fourth quadrant, first quadrant, second quadrant, third quadrant. So that'll help you as well when you're dealing with what trig functions are positive or negative in each quadrants there according. So hopefully that short video will help you in section 4.4 there. And thanks for watching. And if you haven't liked my channel or subscribed yet, make sure you do so.